Hey, Math 30-2. Today we're going to look at factorial notation. So, look at this first example. Considering how many ways there are of arranging 6 different books side by side on a shelf, use the fundamental accounting principle. We calculate the product to be 6 books can go in spot 1, 5 in spot 2, 4 in spot 3, and so on. In mathematics, this product can be written in simplified form called factorial notation. So 6 times 5 times 4 times 3 times 2 times 1 is denoted as 6 factorial. The exclamation mark means factorial in mathematics. So 4 factorial is 4 times 3 times 2 times 1. Determine the value of that. 4 times 3 is 12, times 2 is 24, times 1 is 24. 3 factorial is 3 times 2 times 1. Multiplied by 2 factorial is 2 times 1. So we've got 3 times 2 times 1 is 6, multiplied by 2 times 1, which is 2. That gives us 12. Notice that 6 factorial can be written in a variety of ways. So look closely at that. 2 factorial is the same as 2 times 1. 3 factorial is the same as 3 times 2 times 1. 4 factorial is the same as 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. They're all the same. Just different forms of writing it. So they're all equivalent values. So using that table above, how can we express 6 factorial or 4 factorial? Well, instead of 6 times 5 times 4 times 3 times 2 times 1, we have these 4 factorials. When we divide those out, anything divided by itself is 1. We're just left with 6 times 5, which is 30. So express 5 factorial as a product in 4 different ways. So 5 factorial is 5 times 4 times 3 times 2 times 1. Or it can be 5 times 4 times 3 times 2 factorial. Or 5 times 4 times 3 factorial. Or 5 times 4 factorial. They're all equivalent values. Complete the following then. 12 factorial is the same as 12 times 11 factorial. 8 factorial is the same as 8 times 7 times 6 factorial. Expressed as quotients. 6 times 5 times 4, well, we have to have a 6 factorial there, and we're dividing out, we're missing the 3 times 2 times 1, so we divided out the 3 factorial. Part 2, we're starting with 15, so we had 15 factorial to begin with. And we're missing 11 times 10 times 9 all the way down to times 3 times 2 times 1. So we're missing the 11 factorial. So that's what we divided out. Part E then, without using a calculator, simplify. Well, 10 factorial can be written as 10 times 9 times 8 times 7 factorial. I did that because my denominator is also 7 factorial. I can now reduce 7 factorial by 7 factorial, which gives me 1. So I'm left with 10 times 9 times 8. And 9 times 8 is 72, multiplied by 10 is 720. 8 factorial then can be written as 8 times 7 times 6 times 5 factorial all over. We have a 5 factorial in the denominator, and 3 times 2 times 1 is 3 factorial. So I can simplify that. 5 factorial divided by 5 factorial is 1. 3 times 2 is 6. 6 divided by 6 is 1. I'm left with 8 times 7 times 1 all over 1 times 1 times 1 times 1, or 8 times 7 is 56. In general then, factorial notation is written as follows. N factorial is going to be n, and then multiply that by n minus 1, multiply that by n minus 2, by n minus 3, and so on until eventually we're going to get to times 3 times 2 times 1. Note that n is an element of the whole numbers. We can never start with a 3.7 factorial or a negative 6 factorial. N must be a whole number. All right. Also note that 0 factorial is equal to 1. We'll talk more about that eventually. So n factorial, just like if I had 10 factorial, it can be written as n times n minus 1 factorial. Just like we said, 10 times 10 minus 1 would be 9 factorial. N factorial could be n times n minus 1 times n minus 2 factorial. Or we could have said that's 10 times 9 times 8 factorial. So it's the same statement. We're just rewriting it in general like we did with the numbers. We're going to use this idea to simplify some of these examples. So example 1, complete the following. N factorial, if we look up above, that's exactly like saying n multiplied by n minus 1 factorial. N plus 2 factorial means we always start with the n plus 2. You always start with what the original factorial is, and you reduce by 1. 1 less than n plus 2 is n plus 1. 1 less than that is n, and we've got the n factorial there. So that's an equivalent statement. N minus 4 less 1 is n minus 5, less 1 is n minus 6, and so on until we get to 3 times 2 times 1. That means that we should have started with n minus 4 factorial. Example 2. Simplify these expressions then. So for a, n plus 2 factorial can be written as n plus 2. We always start with what's originally given, n plus 2, and we go 1 less than that every time. Multiply that by n plus 1, multiply that by n, and now I'd stop because I notice my denominator is an n factorial. So I've got an n factorial in my denominator. I can now divide out the n factorials. N factorial divided by n factorial is 1, so I'm left with n plus 2 times n plus 1. And we can leave that as a product. That's fine, we don't have to expand that out. All right. N minus 2 factorial over n minus 1 factorial. Well, the thing to look at here is I notice that n minus 1 is greater than n minus 2. So I'm going to keep my n minus 2 factorial in my numerator. I'm going to start rewriting n minus 1 factorial as n minus 1. 1 less than that is n minus 2. I notice that's already in my numerator, so I'm going to write that as my factorial. I can now reduce n minus 2 factorial with n minus 2 factorial, and I'm left with 1 in my numerator and n minus 1 in my denominator. Part C. N factorial is written as n times n minus 1. Well, that's what my denominator looks like, n times n minus 1. But we have to have something more, so I keep going, n minus 2 factorial. And I can reduce my n's. N divided by n is 1. N minus 1 divided by n minus 1 is also 1. So the simplest form would just be n minus 2 factorial. Example 3, now we're going to solve an equation algebraically. So the left side, we're going to do exactly what we were doing, and we'll keep the right side as 42. So n factorial can be written as n times n minus 1 times n minus 2 times n minus 3 all the way down to times 3 times 2 times 1, or I can say that's n minus 2 factorial. I notice there's an n minus 2 factorial in my denominator. That is why I stopped in my numerator. Remember, this whole thing still equals 42. Next, I can reduce n minus 2 factorial with n minus 2 factorial. That gives me n times n minus 1, and that will all equal 42. Now we could expand this out, set it equal to 0, get ourselves a quadratic equation, factor it, or you can recognize in factorial notation that the n's must be whole numbers, and ask yourself what two whole numbers that are consecutive will multiply to 42. Well, those two numbers are 7 times 6 equals 42. So therefore, we know what n is. N must equal 7. Factorial notation on a calculator. Well, you guys can try that work on your calculator. To find the factorial button, so the button steps in your calculator, you'd hit the number 6. Then you'd hit your math button. Then you would go over to, in that menu, you'd go over to probability. And then you would go down to part 4, which has the factorial notation. So 6 math probability down to 4, which says factorial, and 6 factorial will give you the value. And 9 factorial, same idea. All right, so if you do that with your calculators, value of 6 factorial is 720. The value of 9 factorial would be 362,880. To simplify a quantity like 10 factorial over 7 factorial, 3 factorial in the calculator, we must Remember to put the denominator in brackets. All right. Otherwise, it's not going to work. So try that. Put it in brackets. We should come up with 120. Doesn't matter which way we do it. If you look at it to verify it, well, 10 factorial can be written as such. 7 factorial is same denominator, and 3 factorial is 3 times 2 times 1, which is 6. So I can divide the 7 factorials out. That gives me 1. 9 and 6 are both divisible by 3. 8 and 2 are both divisible by 2. So if you multiply in the numerator, 4 times 3 is 12 times 10 is 120. All over 1, you get the same answer. So calculate the value of each of the following. Do that with your calculators. Make sure you come up with the correct answers. I will give them to you. You see if you get them. All right. First one is 74,046. And the second one is 66,045. Excellent. So I'd like you to try questions 1 through 6. Then you come back and do part 2. All right.